Let's consider example 1. A stone is dropped from rest. Find its velocity after 2 and 3 seconds. In all problems of this kind, you should draw your axis system so I understand what axis system you are working in. And I strongly recommend that you always work in normal coordinates x and y. Okay, so let's write down now the 3 independent equations of motion that we know. The first equation, in distance, I will write using the letter S to represent either x or y, depending which direction we're considering motion in. So the first independent equation is S, distance, is equal to initial velocity times time plus a half acceleration times time squared, where S is either x or y and represents distance. The second independent equation we know is that the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance, where again distance is x or y. And the last independent equation that we know is that the final velocity is equal to the initial velocity plus the acceleration times time. Now, in this equation, we're told that the stone is dropped from rest. Rest implies that it's not moving, so we know that at t equals 0 seconds, the initial velocity is equal to 0 meters per second. So we can calculate the velocities that we're requiring as final velocity using equation 3. And as the initial velocity is 0, equation 3 simply becomes Vf is equal to acceleration times time. What acceleration are we talking about? We're talking about the acceleration due to gravity, and the acceleration due to gravity is downwards in our coordinate system, so the acceleration is minus g, where numerically g is 9.8 meters per second squared. So including all of that information, the equation that we actually will use is that the final velocity is minus 9.8 meters per second squared times time in seconds. And the seconds and the time will cancel with the per second squared to give meters per second, which is the correct unit for velocity. So we haven't made any stupid mistakes. Let's continue to check we haven't made any stupid mistakes and calculate, although we weren't asked for it, the final velocity at time t equals 0 seconds. If t is equal to 0, then on the right hand side we have 0 times 9.8, which is 0, and we have meters per second squared times second, meters per second. So as required, for time t equals 0, the final velocity is equal to the initial velocity. Now let's do the two we were actually asked for, which is the final velocity at time equals 2 seconds. So substituting in 2 times 9.8 should be very close to 20. It's actually minus 19.6 meters per second, and the minus sign tells us that the velocity is downwards in our diagram, that the stone is falling downwards. So that makes sense. And lastly, we were asked for the velocity at time of 3 seconds. Substituting 3 into this equation, we should have something very close to 30, and indeed we will find minus 29.4 meters per second. So we're done, and being proud of ourselves and wanting to make the marker's job easier, we will indicate clearly where the answer to the problem is on our paper. And of course, if you do not have a highlighter to do this with, then by all means draw a box. And we're done.